Oh, you can't see what I'm doing. There we go. So find fx and fy, and then what's step 2? Plug in 1, 2. So this is a vector. Let's just talk about 2. Let's not do it. Let's talk about the process. The directional derivative at the point in the direction. So is that a vector or a scalar? Scalar. It's a scalar, yes, exactly. 3, the gradient, is that going to be a vector or a scalar? Vector, nice. Does it give us a point for that one? No. No, it doesn't give us. And what's different about that one too? Or what's between going from 1 to 3? There's a z. So how many components are you going to have? 3. And you have 3 components, exactly. Nice. And for 4, what is it asking you to find?
The second order derivative.
Second, is that going to be a scalar or a vector? It's going to be a scalar. Well, is it going to be a numeric scalar? No, it doesn't give us a point, so you can expect to have x, y, and or z in there. Do you understand the process for each of these? Okay, we'll put a pin in these right in terms of x, y, and what? And z, right? Now, what is it? So you have x, y, and z, right? So if you wanted to actually find partial f, if you actually wanted to find, if you wanted to find partial f with respect to x, but we know that z is in terms of what? X and y, right, exactly. So if you wanted to actually do this right here, if you want to find partial f with respect to x, what would this be equal to? How many paths do you have?
2.
You have 2 total paths, right, to get to x. You have this x path, and then what do you have?
The second.
The second one, right? So that first path, what do you end up with? What do you have? Partial f with respect to z, and then what? Z, partial x, exactly. If you do the same exact thing with y, what do you end up with? You end up with 0 equals what? Partial f with respect to partial y, thank you, plus, well, I'll just do the paths here. So the paths now are purple and purple. Plus what? Partial f, partial z, partial what? Partial y. So does that isolate nicely? Yeah, it does. That's why. That's what it does. Okay, let's find. You've used tables of values before to find partial derivatives. You've found those before. You know, it's careful. You have to make sure you subtract the right things and add the right things. So what is it asking you for here? It's asking you for a second order partial derivative evaluated at a point. And just so we can match our work to what's done in the book, let's not do the method that I'm more comfortable with, which is pick a point before and a point after. Let's start and go forward 1 point. Can we agree with that? Let's take the point we're at, 1, 2, and go forward, as opposed to bracketing. Do you understand what I'm saying?
Yeah.
Because I want our work to match what is in the book so that we can feel better about what we're doing. Do you understand? Got it? Remember, there was this constant like having to check, and just for consistency's sake, I'm just saying that right now, okay? 1, 2. And how do you go about calculating fx at 1, 2? What do you fix?
Y.
The y value. You fix the y value. So they do. So look, it's you know, it's challenging here. So you have f of 1.12. So that's this one right here. So that's the 9.6. And what do they subtract from it? The 8 right there. So they're calculating this distance because what's being held constant right now? No. What's being held constant right there? The y is constant. So they subtract 8 from 9.6, and what do you divide by? 0.1, which is 1.1 minus 0, right? So that's fx at 1, 2. So they did fx at 1, 2. So then what do they have to calculate? Fx at 1, 2.2. 1, 2.2. So they calculated fx here, and then they also calculated fx 1 unit ahead. Why did they do that? Why did they do that? Because overall, what are we calculating? F sub, what's the outer one? Y. So what's being fixed if you're calculating fy? The x. So they calculated fx here and fx here.
Why don't they just calculate fy there?
Stop, hold on. We're doing the rate of change of y next. Okay, so just watch real carefully. I'm gonna do my best here. So they calculated fx at 1 comma 2, and then they calculated at 1 comma 2.2. The reason they did this was because fxy at 1.2, what are they doing to calculate that? So they did fx here, sorry, I'll keep that in there, and fx right there. So what did they do next? Different numbers to come up with. So if you wanted to do it for fy instead, to do the other one, fy right here and fy right there, because overall, what are we calculating? The partial with respect to x, the partial with respect to x, so y needs to stay constant. Overall, so I guess the best way, if you want to take away one thing, look at the outer one and really, really focus on that. So what's the outer one right here? X. So what's going to stay constant overall? Y. So if y is staying constant, you're looking at the rate of change with respect to x when you keep y constant. So you need to do fy at these two values, because on the horizontal, what type of value are you staying constant? No. Y is constant. So you're calculating fy here, you're calculating fy there, and then you are subtracting and dividing and finding the difference in dividing. How do you figure out fy in each of these cases? Well, that's what it has right here.
But it's like, so you're just like changing the values that you would use to do the second.
Correct.
Before you.
Correct. So instead of doing like 9.6 minus 8 divided by 0.1, we find the fy. So how do you find the fy right here? How do you find the fy right there?
Keep x constant for each one, so you move down the
So you do 12.88 minus 9.6 divided by 0.2. That's what you get right here.
Yeah.
And then you do 10.65 minus divided by 0.2. So those are your two values, right? So those are the fy's in each of these cases. And then you subtract them and divide by 0.1. This, I'm not kidding, this is not easy to see because there are so many numbers. So I guess that I think right now, what I'm judging by your reactions and my own internalization of the process, if you want to focus on one thing, focus on the outer one. Focus on the outer one. So what does this mean? If we're doing fyx, so if x is on the outside, which one's going to stay constant? The y value is going to stay constant. So what do you calculate at the constant y values? Fy. You calculate fy. And then you have to be like, okay, if I calculate fy, that means I have to take x constant. So that's why we subtract this from this, and this from this, and divide by this distance. And then we take these two values, subtract this from this, and divide by that distance.
But then when you're doing like f of x, you still keep only one with the column.
Exactly.